Okay, let's start. Well, today we will see several problems, how to solve these problems. Okay, mainly problems regarding the transformers. Well, the first problem, okay, let me move it a bit higher here. Okay, first problem is about application of loosely coupled transformer. Okay, loosely coupled transformer is the type of transformer, type of real transformer, where the coupling coefficient is okay less than 1. Two coils, each with inductance of 10 millihenry. Okay, we have two coils, first coil and second coil. Okay, each with inductance of 10 millihenry. L11 is 10 millihenry and L22 is also 10 millihenry. Are placed next to each other to form a transformer. Okay, it was determined that coefficient of coupling between coils is 0.1. Coupling coefficient is 0.1. One coil designed as the primary is connected to a sinusoidal current with amplitude 1 ampere and frequency of 100 kilohertz. Okay, first coil is, let's say, is primary coil. Second coil is secondary coil, and let me call I01. The amplitude of current in the first coil is 1 ampere, and the frequency of the current is 100 kilohertz. Okay. First of all, let's convert all these numbers into SI units. Okay, 10 millihenry is 10 to the power of minus 2 Henry. This again 10 to the power of minus 2 Henry. Okay, K is dimensionless. I01 is 1 ampere is in SI units, and 100 kilohertz in SI units will be 10 to the power of 3 plus 2, 10 to the power of 5 hertz. Sorry, here I did mistake. Here should be kilohertz, and this is 10 to the power of 5 hertz. So, okay. Now, let me scale down one moment. So, these are given, and the question A is asking, these are given, question A is asking, calculate the electric motive force in the primary and secondary coils with the secondary open circuit. If our secondary coil is open circuited, it means that current through the secondary coil will be 0, and for this case we need to find electric motive force 1 and electric motive force 2. So first let's compute this, and after we switch to the question B. Okay. For the real transformer, we had the equations. Electric motive force 1 was equal to L11 di1 over dt minus K L11 L22 di2 over dt. Okay, and electric motive force 2 was equal to K square root of L11 L22 multiplied di1 over dt minus L22 di2 over dt. So according to our problem, according to the question A, I2 was equal to 0, so it means that this term is 0 because here we have I2, here we have I2, and again for this also this term is 0. Okay, now let's compute electric motive force 1. Electric motive force 1 equals to L11 di1 over dt. Okay, what is I1? So L11 di1 over dt. I1 is given as amplitude of I1, which is I01 multiplied. It was said that the current is in the form of sinusoid. It means sine. It will be sine omega t. So I0 is given 1 ampere. Omega, well, is not given. Omega is equal to 2pf, which is where f is frequency and f is given. So we can write for the I11. Okay, for I1, we can write 1 multiplied by sine 2p 10 to the 5t. Okay, we found I1. Now, here we need the derivative of I1. So let's compute the derivative of I1 also. Okay, let me move this. Let me scale down and move it. Okay, I move them here. Okay. Okay. What is the derivative of I1? So L11 is from the equation, and derivative of I1 is equal to omega multiplied by I01 multiplied by cosine omega t. I01 cosine omega t, and if we write the numeric values, L11 was equal to the 10 to the power of minus 2 multiplied. Omega, we said, is equal to 2pf multiplied by 2 multiplied by p multiplied f was 100 kilohertz multiplied I0 was 1 multiplied by cosine omega t volts. So
Tushundim aka.
Yes,
Nega mana cosinus bo'lib ketdi? Sinus emasmi?
we are taking the derivative of I1. Look, here we have the di1 over the t.
Ha, bo'ldi.
I1 is sine. When we take the derivative, sine will switch to cosine. Sine will switch to cosine, and also the omega will go here.
Bo'ldi.
Okay. Okay. Let me scale down this as well. So okay, and now the electric motive force 1 will be equal to sorry, I'm writing in blue. Electric motive force 1 will be equal to, so 2 pi 10 to the 3 cosine omega t, or instead of 2 pi we can write 6.28 multiplied 10 to the 3 cosine omega t volts, or you can write also 6.28 cosine omega t kilovolts. So now let's compute electric motive force 2. Electric motive force 2 is given by this equation, and if we want to compute electric motive force 2, so we have electric motive force 2, which is equal to K. So electric motive force 2 is equal to this expression, where this term is 0, only in the case of our problem, not in general. Don't forget. K L11 multiplied L22 multiplied di1 over the t. So in our case, L11 and L22 are equal. They both are equal to 10 to the minus 2, 10 to the minus 2. They both are equal to 10 to minus 2. So from the square root, we get 10 to minus 2. And we also know the derivative of di1 dt. So we can write directly. This will be equal K multiplied 10 to minus 2 multiplied derivative of di1 dt is omega multiplied I01 multiplied cosine omega t, and this equal to K is 0.1 coupling coefficient. Okay, here 10 to minus 2, 10 to minus 2 multiplied. Omega is 2pf, which is 2p F is 10 to 5 multiplied. I01 is 1 multiplied by cosine omega t. And if we compute the numeric value of electric motive force 2, we get okay, 10 to minus 1, 10 to minus 2, 10 to minus 3, plus 10 to minus 5, 10 to 2. We have 6.28 multiplied 10 to the power of 2 multiplied by cosine omega t, which is 2p 10 to the 5 t volts. We have found electric motive force in the secondary coil as well. This is equal to 628 cosine 2p 10 to the power of 5 t volts. Okay, if you pay attention here, we have the amplitude of 628, and in the first coil the amplitude was 6280, 10 times more. Okay, let's switch to the second part of our question. Second part, B. It is saying, sorry, where is blue? Part B. If a current of amplitude 0.05 is drawn from the secondary circuit, so it means that from the secondary circuit we have the current equal to 0.05 multiplied by, well, in the primary circuit we have I01 sine. In the primary circuit we had I01 sine omega t. In this, if the in the primary circuit we have sinusoidal current, in the secondary circuit we will have again a sinusoidal current. It means amplitude of 0.05 ampere multiplied by sine omega t. Also the frequency omega will be the same for the primary and secondary circuit. So the question B, if I2 is equals to 0.05 ampere sine omega t, we need to compute again electric motive force 1 and electric motive force 2. So we will use the same equation as these two. Sorry. Okay. We will use the same these two equations. Only in our case, in the case B, this term and this term are not zero. We need to find the values of these two terms also. So let's write once more. electric motive force 1 equals, let me reduce this, L11 multiplied by di1 over the t minus k L11 L22 multiplied di2 over the t, and the electric motive force 2 is equal to k L11 L22 di1 the t minus L22 di2 over the t. So, sorry. Okay. Let's start by computing electric motive force 1. Which is equal to L11 di1 over the t minus k L11 L22 di2 over the t. So if you pay attention, we have already computed this part. We already know the value of this part. We need to compute only the second part, and then after that subtract it from the first part. So let's for that reason, let's compute the derivative of di2 over the time. So this equals to d over the t. di2 was equal to 0.05 sine omega t. And the derivative will be equal to, so derivative will be equal okay 0.05 omega 0.05 omega cosine omega t, and which is in turn is equal to 0.05 multiplied 2 pi multiplied f is 10 to the power of 10 to the power 5 cosine omega t, and what we get 0.05 multiplied by 2 is equal to 0.1. Perfect. So 0.1 multiplied by 10 to the power of 5, which is 10 to the power 4. Now we get di2 over the t will be equal to 10 to the power 4 multiplied by cosine omega t. Okay, here I'm writing omega just not to write long numbers. keep in mind that omega is equal to, so keep in mind that omega is equal to p multiplied 10 to the 5, or okay, 2p 10 to the 5. So now we know the derivative of I2 with respect to time, and we get the we get electric motive force 1 is equal to, first, L11 di1 dt. This we have already computed, is equal to, okay, this is equal to 6 point here 6.28 10 to the power 3 cosine omega t. Okay, 6.28 6.28 10 to the 3 multiplied by cosine omega t minus now the second term, this term is k is equal to 0.1 multiplied square root of L11 and L22 is equal to 10 to the minus 2 multiplied di2 over dt is this, is equal to 10 to the power 4 cosine omega t. And if we compute all this, we have 6.28 10 to the 3 minus 10 multiplied by cosine omega t, and this doesn't change a lot our result by cosine omega t. Okay, now let's switch to electric motive force 2. So electric motive force 2 is given here. Copy. Not. Okay, electric motive force 2 is given here. Now we know all the values. We know the values of di1 dt, di2 dt, and we know this one is equal to, from our previous problem, This one is equal to 6.28 cosine omega t. So this one is 6.28 10 to the second cosine omega t. And what about this one? This one is L22 is 10 to minus 2 multiplied di2 over dt. We computed here is equal to 10 to the 4 cosine omega t multiplied 10 to the 4 cosine omega t. And okay, finally electric motive force 2 equals to 6.28 10 to the 2 cosine omega t minus 10 to minus 2, 10 to plus 4, 10 to second power cosine omega t. And finally electric motive force 2 is equal to 6.28 minus 1 10 to the second power cosine omega t, which is 528 multiplied by cosine omega t volts. Well, as you can see, when a little current occurs in the secondary circuit, even a little current affects, in our case, it is affecting almost 20% of the voltage. However, this current is not affecting a lot our primary circuit. Okay. The voltage in our primary circuit, literally doesn't change. Why? Because of the linking coefficient or coupling coefficient K. Because of that coupling coefficient is very low, the current in the secondary circuit almost doesn't affect the electric motive force in the primary circuit. And vice versa, in the secondary, the current in the secondary circuit affects a lot the electric motive force in the secondary circuit. In our case, it is affecting almost 20%. It is reducing the voltage in the primary circuit almost to 20%. Okay, now let's look at another problem. So let's see this, or first of all let's see this problem. Okay. The ideal transformer. An ideal transformer has a primary to secondary turn ratio of 10 if the transformer's primary coil is connected to 110 volt and transfers 150 watts calculate the voltage and current in the secondary circuit, the current in the primary circuit, the impedance of the primary and secondary coils. What is the ratio between the impedance in the primary and secondary coils? So it is saying an ideal transformer has a primary to secondary turn ratio of 10. Okay. And 1 over N2 equal to 10. Primary to secondary turn ratio. So the voltage in the primary turn is 110 volt, and power transmitted in the transformer through the transformer is 150 watt. Now we need to compute a voltage and current in the secondary, V2 and I2. So let's compute directly. We know for the transformer N1 over N2 is equal to V1 over V2. So from here we have V2, which is equal to V1 N2 over N1. And the value of V2 so V2 V1 is 110 volt multiplied N1 over N2 is 10. Okay, instead of N2 over N1 we can write let me write 110 volt multiplied N2 over N1. So instead of N2 over N1 I can write 1 over N1 over N2. And this will be equal to 110 multiplied 1 over N1 over N2 is 10. And we have 11 volts. Okay. Now, so let me sorry. Okay, in order not to confuse you, let me move all this to the left hand side, and on the right hand side I will write the expressions for current. Okay, I will move it here. This one I will move a bit higher. So, okay. We need to find current in the secondary circuit. How do we find current? So, the power transmitted through the transformer is not power transmitted through the transformer is not changed for the ideal transformer. That's why power is by definition is V1 I1. If we are dealing with an ideal transformer, power transmitted will not change. So it will also be equal to V2 I2. And okay, from this equation we can simply find I2 as equal to P over V2, and P is 150 watts. V2 we found as 11 volts. 11 volts, and okay, 150 divided by 11 equal to 13.6 amperes. Okay, we found the current in the secondary circuit. Now, the next question is asking the current in the primary circuit. Well, B. The question B. Current in the primary circuit. Okay, again, for the ideal transformer, we have the ratio N1 over N2 equals to I2 over I1. From this ratio, we can find I1 as I2 N2 over N1. Yep. Or we can write again I2 multiplied 1 over, sorry, let me write like this, 1 over N1 over N2. So I1 will be equal to I2 over 10, which is 1.36 ampere. Okay. Okay. The the impedance of the primary and secondary coils. What is the ratio between the impedance in the primary and secondary? Well, as we know from the definition, okay, from the definition, impedance is equal to V over I. So in our case, Z1 is equal to V1 over I1, which is 110 volt over 1.36, and we have okay, we have 81 ohm.
0.88.
Okay, I'm writing 81.
Okay.
Approximately. And impedance of the second is V2 over I2. It's awful. It's awful. V2 over I2, which is, okay, 11 volt over 13.6, which is 0.81. And the ratio between impedances of Z1 over Z2 is equal to 81 over 0.81, which is 100. Okay, according to the definition for the ideal transformers, which we already know, Z1 over Z2 was equal to A squared, or the square of transformer ratio. In our case, transformer ratio was 10. It was given by the problem. Transformer ratio was 10, and the impedance ratio we found as 100, and 100, and this equation works well. Okay, what is not clear?
It's clear. Of course, its answer for B is 10. Yep, correct answer for B. 10.
No, the answer for B is asking the current in the primary.
Oh, I know. I mean C paragraph. For C paragraph, 10 answer is correctly. Yep.
100 is correct.
100. You divided Z1 divided Z2 and equal to A squared 2.
Yep. Exactly.
Why A squared 2? Teacher, can you explain it?
You are asking about this?
Yes. Exactly.
This we have already derived this equation in the previous lectures, and it is saying this is the like a definition.
On definition.
Okay,
Oh.
look, for the ideal transformer, the V1 over V2 was equal to N1 over N2, which was equal to I2 over I1, and all this was equal to A, where A is transformer ratio. Yep. And we have derived another equation where it is saying impedance of primary circuit over the impedance of the secondary circuit will be equal to the square of transformer ratio.
Okay,
it comes from where? Impedance of the primary is V1 over I1, V2 over I2. Okay, V1 over V2 multiplied, we have I2 over I1. Yep.
Yes.
And okay, this one is equal to A. This one is again equal to A. And the ratio of impedances is equal to the square of transformer ratio.
Okay, I got you.
Okay.
Thanks, teacher.
Okay, you are welcome. Well, try to do more exercises at home, and if you have problems, you may connect me by Telegram,
Yes.
Okay. In that case, we can finish. I think
our lesson is over. Yes.
Yep. Only you is here. You are here. Okay, doesn't matter.
Like for you, I'm here. Thanks, teacher.
Okay, bye.